Today I'm going to take another look at surface mount soldering, but I'm going to try a different tactic. In our last SMD soldering video, you'll remember we put this together using the soldering iron. It wasn't a great experience. It was doable, it was fun at times, but it's not something I really want to do. The main reason I wanted to learn how to solder SMD devices better though was because I want to do more electronics and I want to use surface mount devices for that instead of through-hole components. One of those devices is LEDs. I'm going to have little LED indicators on some of these circuits so that I can see what's happening at any different point in the process at any given time. But I didn't know what size LEDs I wanted, what color they were going to be, and I found a really good deal on AliExpress from one of their sellers, and I'll link to them down in the description below, who had 7 different sizes in 5 different colors. So I bought all of them. I bought every size and every color combination they had. I bought 100 of each except for the whites, which I bought 200 of each size. But I got one of them mounted on here so I can figure out what kind of resistor I'd need in order to have a nice, bright enough to see but dim enough not to blind me or give me headaches LED on my circuit board. As I said though, soldering these with the soldering iron was a bit of a pain and I'm going to have a lot of soldering to do, so I ended up buying the ubiquitous 858D. And I also bought another one of these so I could use this video to talk about surface mount soldering or learn surface mount soldering with the hot air station. But then I had a thought. I've got these 4300 LEDs. Why don't I design my own board and do that instead? So that is exactly what I did, and I don't have everything here right now to solder this together, but this just arrived and I was excited and I want to look at it, and well, I had to do it on camera. This is actually the first time I've ever ordered PCBs from anywhere, and this is not sponsored by JLC PCB, but that is where I ordered these from. I wanted to see what they were like, and well, let's find out. And oh, look at those. I'm a little disappointed. Every time I see one of these get opened on YouTube, there's a pen or a keyring or something inside and I got nothing except my boards. But I got my boards. Oh, how cool are these? So here we are with our PCBs. And the goal of this board is basically just to give me something that I can solder all the LEDs to as a reference. I just wanted something that I could apply power and see all of the LEDs all at once, and that's it. So we've got sockets for 3 different types of USB port at the top. This one's for a mini, but the ones I've ordered have a different footprint, so I don't think I'll be using those. These are for a Type C USB, and oh, actually, where's that bag? So here I have a bag of USB sockets and bits that I set aside for these boards. Now we get to see if the footprint's right and if they fit. Now, obviously you wouldn't have a whole bunch of USB cables going into this thing, but I wanted to be able to have this so that no matter what cable was nearby when I needed it, I could just plug it straight in without having to worry about it. The ones I use most common these days are Type C and Type B. The only issue I had with this footprint, and I didn't notice it until after I ordered them, this one has holes. These are the mechanical holes that affix the socket to the board. But on the Type C sockets that I've got, these 2 at the front are actually surface mount. I did notice it and I did make my own custom footprint just for these, but for these first sample of boards, I think they'll be fine just being held down by the back too. And I'll get at least some mechanical connection there with those. So I'm happy with those for now. So when those are both on, you'll have 2 different USB power options. I also added a couple of pins here so that I can just put standard pin headers on there and connect it from a benchtop power supply or whatever. But each one of these, you'll see there's a resistor and an LED. Every single one of these resistor LED pairs is connected in parallel so that they get the full 5 volts, because almost all of my circuits are going to be powered by 5 volts. I added You might have already spotted these when I turned it over before. I added some big white blocks for the silk screen. These allow me to write some notes on the back in case I need to, like who I ordered the LEDs from, because I want to try LEDs from a bunch of different companies, and this gives me the option of having little sample boards available for all of them. But right now I gotta wait for all the other bits to arrive, and then we'll start soldering. So I will continue this video in a few days. And finally it goes into focus. Alrighty, so it's been a couple of days. Here you can see I've got my board. I've had a few other things arrive too, such as this solder paste, which, yes, it's in a pot. I ordered some of the mechanic leaded 6337 solder paste, 183 degrees. To apply this, I've seen a lot of people in their videos using a cocktail stick. I decided I was going to get some plastic cocktail sticks. The only problem was the only plastic picks I could find were these 80s beauties. So I bought a packet of these for laying out my solder paste. You remember this? This is the USB-C sockets that I had. And they've got 2 pins on the back that go into the holes. But then on the front, instead of having 2 more pins, it's 2 little flaps that go on surface mount pads. Rather than trying to do that, I thought I'll just order a handful of the right one that fits this footprint. So these have 2 little sets of legs, and they do fit perfectly. I checked. I've also got my Type B socket here, that way around. But right, I think it's time to look through these LEDs and get some solder paste on the board and see what's what. So I have decided that what I am going to do is I am just going to do the top row on here first. I was thinking about just slapping them all on and hope for the best, but I think I'm going to go across the top row, which are 5730 size. I'm going to go red, green, blue, yellow, white, and warm white. And this is the only size that I actually have warm white in. This was the only size they had of warm white. Also, I'm dragging out the multimeter here because I want to make sure that these are going in the right way. I'm going to move this out of the way. Here is our red LED. And I got it in diode mode, and if I touch those, not lighting up. If I touch that way, it lights up. So I know this side on the left is the ground, which means it goes that way around on the board. So I'm going to do that for all of these colours. Oh, isn't that interesting? Right, let me zoom you in. So here on the left, we have the red one, and both of these are oriented the same way around. And if I go that way, the red one lights up. If I do it on that one, the yellow one doesn't light up. The reason is because when they made this, they messed up and put it the other way around, which is frustrating because underneath these, there are pins like this. Now on this one, the right side here is the positive, and on here, the right side is the negative. But if I pop my meter into continuity mode, and I touch the middle bit and ground, nothing happens. If I touch the middle bit and positive, you can hear it beep. Okay. Now on this one, if I touch the middle bit and what should be ground, but is actually positive, nothing. And if I touch the middle, which should be positive, to the positive, which is actually ground, yeah. So I need to cut the track on the PCB, because on the PCB, I have connected this pad and this pad with a little trace across there. So I'm going to have to cut this one so that when I solder this in the wrong way around, that doesn't connect with the middle pad. That's frustrating. This is why we always test our LEDs to check for polarity, because every single one of these, with the exception of yellow, is oriented the same way. Yellow is the wrong way around. So here you can see these two pads have continuity. I need to cut this so that they don't. So now that should be enough. There we go. So these pads no longer have continuity. These do, and these do, but these don't. This is the gamble you take when you buy random generic LEDs on AliExpress with no data sheet. This is also why I wanted to build up sample boards like this, so I can remind myself, oh, some of these are a bit funky. On all of them except yellow, I'm putting solder on the middle pad as well. And this is a really therapeutic way of putting down solder paste. I'm glad I'm not doing it for a living. I wouldn't want to do this all day with a toothpick. I think this is where I'd probably invest in stencils. But for a little one-off board like this, that I'm only going to be putting together occasionally, I think it's going to work quite well. So that's it. We've got solder paste on all of those. I'm going to pop a bit more on that, I think. And now I'm going to pop these in place. So I'm going to fire up my hot air station, and then we'll get all these fixed on. Okay, you can see now that I've swapped to my macro lens that these three are all in one particular orientation. So's that one. You can just about make it out on that one. See how it's got that long bit down that one side, and it's on the left. Here, it's on the right. It's annoying. I am going to fire up this hot air station. There seems to be two schools of thought on this. One is to just, get it around 300 and it takes as long as it takes. The other one is to go higher for a shorter amount of time because the components apparently can take the high temperature, and they'd prefer a higher temperature for a short amount of time than a lower temperature for a longer amount of time. So that's what I'm going to try, and we'll see how it goes. So I am at 420 degrees, and now I just got to wait for this to heat up, which actually doesn't take too long. You might notice also I've put a slate down underneath, a little slate tile underneath the board, just to try and help protect the desk from the heat a little bit more. Plus, the slate will actually retain the heat, which will give the board some heat from underneath. But right, let's give these some air and warm up the area around the board and try not to melt the LEDs. Oh, and there goes the first one. Well, there we go. That's those on. I'm going to get my meter again, and we're going to just double check that they all soldered correctly. So this side of each LED is the negative, and this pin here is positive. So we'll pop you in LED mode again, and you can't see it on this lens, but I am in diode mode. And we'll pop you there, and you're working. You there and you there, you're working. You and you. You and you are not working. We'll come back to you. You're working. And you're working. Right. So you are working there. Why is there no continuity there? I wonder if I've bridged that other pad. Let's check continuity on that again. Why have I lost continuity there? So we've got continuity to ground. We've got continuity to 5 volts. A resistor goes in there, then that goes to this. Oh. Hello, Future John here. I thought when I designed this PCB, I'd wired these LEDs up like this. And when I cut the track, all it would do would disconnect the middle pad. And all would be right with the world if I got a stupid LED that was wired the wrong way. But no, what I'd actually done was wire it up like this. So then when I went and cut the track, all I did was disconnect this pad, which meant the pad on the right's getting absolutely nothing, and the pad in the middle is just shorting straight to ground through the LED. Anyway, I spent the next 30 minutes trying to bodge this to get it to work, and it wasn't going to do it. So ultimately I decided, new plan, we're going to forget that this one even exists. We're just not going to do the yellow one. You'll be pleased to know that in the schematic for the Gerber files that are up, I've done it like this. So if you get an LED that's the wrong way around, you can just cut the track. But these all, well, let's do them properly from the pads and just check we haven't killed any of the others. So the others all still work just fine. This is where this little circuit comes into play. This board right here is set up basically, I was just experimenting with a bunch of resistors I had in my bits drawer to try and get this at a brightness where it was bright enough that I could see that it was on, but it was dim enough that it was comfortable for me to look at. The actual resistor value here is irrelevant. It doesn't matter. The only thing that matters here is the brightness of this LED. I'm going to leave this plugged in and at the back of my desk so that I've just got a constant visual reminder of how bright this is, so that as I figure out the brightnesses for these, I've just got something to compare to so that they all look roughly the same brightness. And the way we're going to figure out the brightness we want for this, and thus the forward voltage and the resistor we need, I'm going to run them through my benchtop power supply, because I also just bought the Eventech KPS 1505D variable power supply. It does 0 to 30 volts and 0 to 10 amps. I'm going to show you how we're going to do it, but we're basically going to use it to figure out how much current we need to put through each of these and what that forward voltage works out to in order to get them all roughly the same brightness as this one. So let me go wire that up. You can see how that works. Here you can see we have the data sheet up for a standard LED, and we're going to have a look through the specs here, and you'll see the forward voltage is 2 volts at 20 milliamps, but it's not. Further down, a chart contradicts what it said earlier on in the data sheet. This says 2 volts, 20 milliamps. This at 2 volts says it'll put about 5 milliamps of current through it, and to get 20, you need 2.2. Now, normally, you know, you'd just take this as read. You'd take your power source, in this case 5 volts, subtract your forward voltage, you figure, okay, 20 milliamps, and then you work out the resistor you need to make 20 milliamps of current flow through 3 volts, your remaining after you remove the forward voltage. It's not going to blow it up if it's wrong, but I want all these to be roughly the same brightness, and I don't want them to be anywhere near full power, and we're going to use the benchtop power supply in order to figure out what those voltages are, what the currents are, and then what resistor we need in order to get all of the different LEDs on the board looking roughly the same brightness to my eye, because that's all I care about. Alrighty, so here you can see I've got my Eventech power supply all set up. I've got the positive end just going to this probe that I'll attach to the board. The other side of the board, the ground, or the negative, comes out and goes into my multimeter here, which is set in current measurement mode. And then the output from that goes back into the power supply, completing the circuit so that when we apply power to the board, the current flows through the meter and it can tell us how much it's using. When I apply this to the board, it completes the circuit. There's no voltage being applied, so there's no current going through. So what we're going to do, and I'm going to have to hold this awkwardly so that I don't obscure the view of the LCD, but I'm holding that on that pad. I'm going to slowly ramp this up because this is the coarse voltage adjustment dial and it's very twitchy. And I've got my current dials on here maxed out, so it's only letting through what the LED lets it, because we're not running it at full brightness and we're not running it over voltage. And you see, once we get to around there, 1.45 volts, I don't know, can you see? Yeah, you can just about make it out on the overhead one. If I light it up and then don't light it up, you can see it going on and off, and there it's drawing virtually no current, less than 1/100 of an amp, and you you can barely tell that it's even on, but you can just about tell. All right, so now we're going to ramp it up a little bit in order to try and get this at a brightness that we like, or well, that I like. I'm going to keep going up, and there at 1.79 you can see we're finally getting 0.2 of a milliamp at 179 volts. And it's still a bit dark. You can see it on the overhead, but it's a bit dim. I'm going to keep going up to, there we're at 1.9. I'll go up a little bit, nope, not quite that much. Oh, there we go, 1.98 volts, 1.99. We're a little over 5 milliamps, which is pretty much what the data sheet for that generic LED said for red. So this is actually pretty close. But right, now that we've got this information, I'm going to knock that down one. I want to get that. There we go, 1.98, 5.04 milliamps. So we're going to write that down on the sheet, and then we'll do the maths. I've printed out a sheet with all the different sizes and colours of LEDs on it, so I can write down all the information. And the LED we just did, it had a forward voltage of 1.98 volts with a current of 5 milliamps to give us the brightness level we wanted. Now, to figure out our resistor, we need to subtract this from our source voltage, which is 5 volts. So 5 volts minus 1.98 volts equals 3.02. And now from this we can figure out our resistance, because we just need to look at Ohm's law. Voltage divided by current equals resistance. So 3.02 volts divided by the current in amps, which is 0.005 amps, equals 604 ohms. Now, obviously, there isn't a 604 ohm resistor, so we're going to round that up to the nearest one, which is 620 ohms. And there's our value. That's the resistor we need to make this LED be as bright as it just was, give or take, with a 5 volt power supply. So now I'm going to go through and I'm just going to figure out the values for the rest of these and fill this in, and then I'll be right back. So that's all of them done, and I even did the yellow one, even though it's not on the board, just for the sake of completeness. But now I am going to get all these ones lined up and soldered on as well to fill out these other spots. Alrighty, so here's an interesting one. This time, 2 of them are reversed. The red and the yellow are wired the wrong way around. The little divot in the corner that's supposed to point towards negative is actually pointing towards positive. Fortunately, with these ones, there's no big pad in the middle, and all of these down one side are negative and all these down this side are positive, coming from the resistor. So this time, it's not a problem, but we'll whack some solder paste on there and get these soldered on. Alrighty, so that's the 50/50 soldered on. Let's give these a test and see how these do. Red's working, green's working, blue's working, yellow's working. If I can find a good point to touch this. There we go, yellow's working, and white is working. They did get a little bit melted, not as bad as I thought they'd be. I think most of the others are going to be a bit easier because there isn't as much plastic on them as there is on these. Right, now I'm going to go and just get all the rest of the LEDs on here and then figure out what all the resistor values are. And that's all soldered, and I've been through and done the resistor test on them all, and as you can see, I've printed one because it's a lot neater than my handwriting, but now I know all the resistor values that I want to put with all these LEDs. And for those resistors, I ended up buying a 1206 sample book. As you can see, it's got thousands of resistors at all different values, so every single value that we need on this sheet is in this book. So I'm going to get those on next. So part of the reason I wanted to print out this sheet was so that as I took resistors out of this book, I had somewhere to line them all up that matched with their positions on the board. Obviously, I'm not going to do the yellow one, but I didn't want to put a load of solder paste down on this and then take 20 minutes to pull out all the resistors. So I thought this would be the easiest way to just pull them all out, plop them all down, and then they're all organized in the right places. And then when I've got them all out, I can pop down the paste, transfer them all over, whack on the heat, and jobs are good. It's all right. Time to get these out. I gotta do this really carefully. I've messed up. I know which ones went where though. I'm gonna shift these out of the way so I don't knock them and send them all flying. We've got the board, we've got the solder paste. I got my little my little swords. So we'll get some of the paste on the board and then we'll pick all of the resistors over. There is all the resistors on the board. I'm going to fire up the hot air station and we'll melt some solder. That's all those soldered up. What we'll do to give them a quick test before we put the USB sockets on is we'll just hook the variable power supply straight up to the pins here and see if we can get some power on this thing. Yeah, we've only missed. Alright, so we've missed a red one. This one hasn't soldered on properly. We got two white ones that aren't lighting up, but that's it. So we'll give them a quick reflow and give it another whirl. And there we go, that's all of those. So we'll get the last SMD component on next, which is our Type-C USB port. I think we're good there. I'm going to turn it around and just get a close-up shot on the macro lens just to see if, because it looks like we might have a couple of bridged pins. Yeah, we do. We got a couple. So we'll see if we can get them to flow a little better. If not, we'll attack them with the soldering iron. Nope. We'll attack them with the soldering iron. So I picked up one of these headsets. I actually got this for mini painting, but it works quite well for inspecting electronics as well. It has a little built-in double LED at the front, but with the video lights, I just don't bother with it. So, right, we will see if this can let me get down here and solve this. It looks like we're good. So I'm going to add a little bit more solder to these pads underneath, and we'll just use the regular AIM 6236-2 solder for this. Stick the Type B on as well, and I'm going to solder just one of these in for now, just so that I can make sure that that's tight to the board, which it is, and now we'll do the rest. And that's that. Alrighty, so let's grab a USB-C cable and let me see if I can find a power bank. So we'll plug this into here first, and oh, that's a satisfying snap. And then we'll plug you into here, and that's it. So now I have a board with, well, almost all my LEDs on it. That yellow one still annoys me. In fact, give me a minute, I'll be right back. Okay. I made another one because it was annoying me that that yellow LED wasn't working. So I made another one, and I didn't cut the board on this one. Instead, what I did was I just used a little bit of 3D printer resin, the UV reactive resin, and just basically added a teeny tiny little drop to act as a solder mask over that middle pad. So the connection's still going through, but the middle pad underneath the LED can't contact that. We have one fully working, and I just want to see them both on. They're both working and up and running, except that yellow LED that's going to annoy me forever, even though I have got a fully working board there. In the Gerber files, there'll be a link in the description for this video. This has been fixed so that it links to the outside one instead of the inside one. So if you do get an LED that's the wrong way around, you can safely cut it, and then it won't contact the middle pad at all, and it won't break the connection to the right hand pad. SMD soldering is definitely easier with a hot air station. I need more practice so I don't melt LEDs. But, you know, what can you do? You got to start somewhere, right? I have a few electronics projects coming up. They're essentially one big project. So the time-lapse intervalometer that I made a year or two ago. I had a bunch of people asking me questions about it and how different parts of it work, and a few people wanted me to explain like everything in great detail. So that's what I'm going to do. I've already started working on a series. I want to try and get as many parts shot and filmed and edited and done as I can before I upload any of them, because I want to make sure that I stick with that series. I also want to get part 2 of the gimbal video done, and I got a big bag of bits for that. So that one will be coming soon too. But for now, I think that's it. Like I said, the Gerber files for these will be down in the description. Any suggestions, questions, ideas, let me know down in the comments below. But for now, I'm happy. I've got a board I can fire up anytime I want. I can sit and look at all these LEDs and figure out what size and what color I want to put in my project and what resistor I need to use in order to make them comfortable to actually sit and look at. And yeah, I'm going to need a lot of these in an upcoming project for indicators, so this will be very, very handy. Thanks for watching. I'll see you next time.